The VEX Challenge is part of the academic sports program that's just been initiated this year at Crete Public Schools. It's a competition that we are opening to all students who want to participate in robotics, and it's just one of the sports, one of the academic sports that we'll be including in our program.
My name is Tim Rinker. I'm the coach of the Crete First VEX Challenge robotic team. We started a team this year for the first time in answer to a challenge for a nationwide robotics competition. The competition is made up of teams from all across the country who compete in local events and regional events, and if you are successful in the regional event, ultimately you have the opportunity to participate in a national event. And in 2007, April, that's held in Atlanta, Georgia. The team started in about September, October this year, and actually each year the teams will learn about the essence of the game or the challenge for that year. We started out by building a robot. So the kinds of talents that are helpful or useful or interests have to do with building things. So any person who's ever worked with Legos or K'NEX or the old Erector sets is kind of familiar with the idea of starting out with an idea in mind and putting pieces together. The robot that we build is a little more sophisticated in that you have the opportunity to put gears together in some combination with motors and wheels to provide your drive system. So some of the guys on the team happen to be particularly good at that effort, and we built something that would move. The brains behind the robot actually amount to a small microcontroller. It's a device that has about 8 motor outputs on it and 16 programmable inputs and outputs that allows you to interface to sensors of different kinds. Our first effort, we put on a bumper switch so that when our robot moved forward and ran into something, we could tell we had hit something. But there's also sensors that allow you to follow a line on a piece of paper, similar to some of the Lego type kits. There's sensors that allow you to do a little sonar to find out how far away you are from an object, and a variety of sensors that give you the ability to feel when things have happened, like the bumper switch. We have to program our controller so that it knows how to react when we do hit a switch or have one of the inputs change. And the programming language is kind of interesting. You program on a PC, you drag blocks off of a template and drop them into your program, and that is what gives you the personality for your program. So in our particular team we have several individuals who are pretty good at programming efforts. The final phase of the team, as far as our design and build, had to do with execution itself. The robot runs by itself for 20 seconds, and we have to teach it via program how to respond to its environment. And then for 2 minutes it's actually driven by members of the team. I say members because there are 2 remote control units. One of them typically is used to drive the wheels on the robot, and the second remote control is used to drive the end effectors, or the things that might participate in the challenge. This year's challenge we had to pick up softballs, so we have end effectors that are pretty good at picking up softballs and moving them around. Now, in addition to those basic needs, you also have to have some creativity of how to put all these things together, and some strategies as to how you might participate in the tournament. Tournaments are actually held where 4 robots are on the field at one time. The robots are kind of randomly assigned to a team. So our first scrimmage, we got coupled with another team, and we kind of worked together against the other 2 teams. So you have some strategy sessions, folks driving, people programming, people building the robot. One of the ladies on our team this year actually is responsible for our technical engineering notebook. Documentation has to be kept on every phase of the robot, design details, a bill of materials that includes a list of all the parts. So all in all, one of the things that makes it kind of fun to do is there's a lot of different things that a person can work on, different talents, different interests, can have an effect on which area you choose to participate in.
This is Sasquatch.
As you can see, it's our basic bot with all the basic bot components.
And amenities any bot could ever wish for.
We have the brain, which controls everything. All the programming is put into that brain.
We have our receivers here that tell the bot what to do after we tell it what to do.
And also back to the brain, we have all the motor plugins and other plugins for sensors and whatnot.
But it's more important to realize that we have our wheels here and attached to our chassis, so that way they're protected.
And each wheel has its own motor. It's four-wheel drive.
Yeah.
There's also a motor under each of the front side areas for the swinging arms.
These are used to collect the softballs and occasionally hit things.
We also have a MP3 player, but that is just for decoration, not
It doesn't really serve any
VEX
purpose.
certified. Yeah, as you said before, these are the transmitters which transmit all the information from the controller onto the brain, which in turn controls everything.
We have here a bumper, just in case we run into things. We can actually use this to store a ball here.
And this little orange thing in the brain is a jumper which allows the bot to run in autonomous mode, which is a mode where you don't control the bot for 20 seconds and it just runs off of programming.
And after 20 seconds, then you actually get in and you control the bot for the remaining 2 minutes.
These are our basic robot controllers. As you can see, it's just like mini toy remote control car controllers. For our specific robot, this controller controls the front arms, and as you can see, open, close, right, left, for those who didn't understand how to run this. It's transmitted through this crystal, and the number on it represents the channel it's on the brain that's located on the robot.
This one drives the robot. It operates the wheels. It's like a tank. This to go forward and then backward, and then either left or right. And then you can program it the same as this one. It has crystals, and when we only had one remote, we used these two back buttons to control the arms to go in and out. This, we use a 9.6 volt battery. Rechargeable. That's the only kind of batteries you can use for the VEX remote controls.
The first VEX competition was invented by the inventor, Dean Kamen, who invented the Segway, if you're familiar with that invention. And it's designed to help students develop skills that are very important for growing up and becoming an engineer. So if that's something that you're interested in doing, if you're excited by science, math, technology, this would be a really good class for you to get involved in.